Okay, good morning, class. So at this point, we're looking at, first put our calculator there. What happened to our calculator? It's closed. Let's open it up again. Alright, so we're looking at quadratic equations. At this point, we're busy with... Nope, not there yet. Maximum, minimum values, is that correct? So now we're looking at examples for exercise 2.5, no? Examples for 2.5, and that's on page 28. Okay. So here we tell that every trinomial ax squared plus bx plus c is equal to 0, where a is not equal to 0. If a is equal to 0, then it becomes linear. Because 0 times x squared is basically 0. Okay. That is why they are omitting the fact that a can be any real value other than 0 there. Where a is not equal to 0 has a maximum value or a minimum value. Okay, so which quadratic graphs did we draw last year? We drew the parabolas. No? Another word for quadratic is parabola graph. So if a was greater than 0, who can remember? Would it be going in that direction or in that direction? It would be smiling. Why? Because the a value is positive. So if it smiles, okay, just take it off so I can separate it. So that is positive. So if a is positive, it will have what we call a minimum value. Okay. And of course, if a is less than 0, which means it's negative, then the graph did that, which had a maximum value. Okay, so that's what they're telling you here. As a maximum or minimum value, it is possible to determine the maximum minimum value by completing the square, and that's what we've been doing thus far. Not so. And writing the trinomial in the form of a plus a into x plus p all squared plus q. In example 1 and example 1 is on page 28. Alright, this is write down the maximum or minimum value of each of the following. So if you look at this here, does this graph have a positive a value or negative? Positive. So since a is greater than 0, we say the graph is positive, so the graph will be smiling. Okay. So we say the graph will have a minimum value. Now later on, I'll show you the coordinates of this, how we get the coordinates of this turning point, but that deals with graphs in chapter 5. Okay, for now, you're going to accept that this point here is the additive inverse of this, which is negative 1 and negative 4. Okay, so we say this graph has a minimum value of negative 4 and occurs at an x value of negative 4. Right, you guys understand? Let's look at number 2. What do we say about number 2? This is also positive. So with this graph, we have a minimum or maximum value? Minimum. Graph is smiling. So what is the coordinates of that point? Who can give me the coordinates of that point? It's going to be 3 or negative 3? 3 is going to be the additive inverse, yes? And 5. So we say, what do you say here? The graph has a minimum value of 5 and occurs at x equal to 2. Okay. So any confusion there? You all understand? Okay. Let's look at number 3. Will this graph have a minimum or a maximum value? Maximum. Why? Because of the negative, so it has a maximum value. What's the coordinates of the starting point? Negative 2 and 3. So what can I say about this? There's a maximum value of 3. The highest point that turning point will occur at is 3. The highest point will reach for this the parabola. No? Here the lowest point on the y-axis it will reach is 5. Can you see? So it has a maximum value of 3 and occurs at x is equal to, the maximum value occurs at an x value of minus 2. Does it make sense? Right. Let's carry on here. Let's look at number 4. Okay. Number 4. Does graph have a maximum or minimum? Maximum. Why? Because it's negative. Not so. What's the coordinates of this? 4 and